Okay, displacement and velocity in 2 dimensions. So when you have a vector, we want to see how can we do vector addition. So there's 2 ways to do the vector addition and subtraction. Is just by putting them after each other and finding the overall is one way. But I would like to teach you the other way, which is you turning them into the components and then add them up. Just find a good question. So I'm gonna go over that with you. So I'm gonna do question number 18, then you do question 19, then you do question 20, okay? So determine the vector sum of displacement delta D1, delta D2, and delta D3. I want to add these 3 vectors. What I do, I put them into their components. For example, the first one is 2.4 meter, 32 south of west. Means you start at west, then you go to the south. So this is west, this is south, right? You start as west, then you go to the south. How many degree? 32 degree. The magnitude of that is 2.4 meter. Then you do the same thing. So this is south. It just has a y component. I'm going to show you. This is this vector. This vector is just south, 1.6 meter. And the other one is south of east.
South, yeah.
Means you start at east, then you go to south, 27 degree. The magnitude of that is 4.9. 4.9 meter. Okay, just a little note for you. If you have this vector, you have x, this is your, let's say this is your d. I want to find the dy. And here is dx, right? This d has a 2 component, y component and x component. And this is theta. Remembering that the sine theta is opposite over hypotenuse. Opposite is in front of that. Dy over d. And cosine theta
It's the x divided the.
exactly is adjacent over hypotenuse dx over d. Very good. Now, if I rearrange it for dy, dy is d multiplied by sine theta. Because dy is opposite, it's going to be sine. Dx is adjacent, it's going to be cosine, right? Dx going to be d cosine theta. Now, what I'm going to do, I'm going to do the same thing here. I'm going to find the x and y component of the d1. So d1x, maybe I just use a different color. So d1x, x component here gonna be what? Gonna be adjacent. Adjacent is cosine. Cosine. Gonna be 2.4 cosine of 32. And d1y is 2.4. The y component is opposite. Opposite is sine. Sine 32. But pay attention, this is going to be a negative, right? Because this is the y component here is negative, right? That's why I need to put negative here. Here we have D2x. Do we have any x component here? No. 0. We have y component. D2y is negative 1.6. Do the same thing here. D3x. So x component here is adjacent. Adjacent is cosine. So 4.9, right? Yeah, 4.9.
Time to move cosine 27.
Cosine 27, exactly. And D3y is 4.9.
Is sine 27.
Sine 27. And make sure this is going to be negative.
That's negative.
So I have to put negative. So if I want to add everything, so I need to add total of displacement in x direction. It's going to be D1x plus D2x plus D3x. I need to use calculator to calculate those things. Also, I need to find addition of all of dy. D1y plus D2 plus D3y. So here is x. D3x. This gives me the d total, the d in x direction total. And this gives me the total d displacement in y direction. And then I have to put this component together. But first I need to use calculator to find those numbers and do it. Just a second. So I put it in a calculator, and for D1x, D1y, and all of these numbers to get those values, then I did add up D1x, D2x, and D3x. The result is 2.34. Make sure your x component here and y component here is negative. And D1y, I calculated D2y, D3y, I put in a calculator. I add them up is negative 5.09. Now, here is total x component and total y component, right? Total x component is positive and y component is negative, right? If you put these two vectors successively after each other from the beginning to the end, so that's your vector. So this one is 2.34, and from here to here is negative 5.09. Okay, and you need to find this angle, right? So to find the actual vector, the hypotenuse of that, you can use a Pythagorean theorem. This displacement, total displacement, is equal to displacement in x direction to the power of 2 using Pythagorean theorem, right? Plus displacement in y direction to the power of 2. It means it's numbers that you get is 2.34 to the power of 2 plus negative 5.09 to the power of 2. If you do that, you get 5.6 meter. To find the angle, the tan, you need to take tan inverse. Okay, you know tan is opposite over adjacent, right? Opposite is y component over adjacent, which is x component, exactly. So you have to put, yeah, you don't put the negative because this is geometry, right? You want to find the angle of that triangle. You don't take that negative into account. It's just the geometry of that.
Yes.
Then the angle gonna be 24 degree. And how do you say that? You will say east 24 degree. You can say east 24 degrees south. This is one way of doing this.
Yes.
Or you can say 24 east of south. Means you start with east, then 24 degree east. You start from south, then 24 degrees. Oh, if this is south, okay, just give me a second. So if you put this one in calculator, the tan inverse, I need to correct that. So this gives you 65 point something, 65 point, let's say 6. And then this is your angle theta. Then you can say east 65.6 south. Means you start at east, then you go down 65 points. If this is 65, this is going to be 24. Or you can see that as the answer is here. Oh my God. As the answer is here, it said 24 east of south, means south. You go to south, then 24 degree to the east. Both of that method is good. Make sure the displacement is the velocity. You need to mention the magnitude, which is 5.6, and the direction.